Hey, welcome everyone to the back to school 1Password demo. We are so excited. So 1Password's been around a long time as a password manager, but also we have really amazing developer tools. And also we're so excited about back to school for GitHub and GitHub Education because you know what? It's football season. So I'm a proud Oregon State Beaver. You can see I got my Beaver gear on today because we're playing a game tomorrow, which will be fun. But we're here to talk about developer tools. So I'm super excited to welcome my colleagues Chris and Dustin, who are both senior developers, and they're going to be showing off our VSCode integration, our Git Commit signing, and our SSH agent, and a whole lot more. We have GitHub Actions. There's a whole lot to be explored. So I will welcome Chris to the stage and take it away.
Hey folks, my name's Chris and I'm a senior developer at 1Password. I work on the developer ecosystems team. Today I'm really excited to share with you how we can go beyond thinking of 1Password as somewhere we store logins for websites and apps and start to think of it as somewhere that we can store all of our credentials and secrets for a typical development workflow. Today we're going to go through making changes to files locally, committing those changes to a local Git repository, and pushing those changes to a remote Git repository, in this case, GitHub. Typically, in order to push code to a remote repository, we need to authenticate ourselves with an SSH key. You can see here that I've got my GitHub account settings open on the SSH and GPG keys page. And on here, there's a link to generating SSH keys, which when we click it, takes us through to a portal of documentation. There's a series of articles here. This one, for example, walks us step by step through how to generate a new key with SSH keygen, whether or not we need a passphrase for that key, how we add that key to the SSH agent that's running locally on our machine, and then in the next article, how we get the contents of the generated public key and add that to our GitHub account so that GitHub can authenticate us on the other end. This documentation is fantastic, and by the end of it, we'll have SSH keys on disk that we can use to authenticate ourselves with GitHub. However, this method has some drawbacks. For example, as you've just seen, there's quite a few steps, quite a few commands and different parameters that we have to remember in order to generate the keys and add the keys to the agent. Additionally, this command here copies the contents of the public key so that we can go to our GitHub settings and add the key to our account. If, for example, we were to forget the .pub extension, we would end up accidentally copying the contents of our private key and pasting that into our GitHub account, which is a potential security concern. Additionally, the result of this whole process is that we have a private key on disk, which is also a potential security concern. But there is a different way, a potentially simpler way. If we switch to the 1Password application, unlock with Touch ID, and we head up here to the New Item button, in here there's an SSH key item type. With this, we can generate an SSH key in a few clicks. The default setting here is ED25519. This is the fastest and most modern standard, but we can also use RSA keys with a variety of bit lengths. We're going to stick with ED25519 because this is the fastest and most modern standard. So we're going to click the Generate button, and we've got a brand new SSH key. We can give this a name, GitHub Demo Auth. We're going to save that to our private vault. You'll see here we've got the SSH key that we just created, and it has a banner. The next step here is to turn on the SSH agent. So there's an SSH agent built into the 1Password application. If we head over to the developer settings, we can click the button here to set up the SSH agent. It will first ask us whether we want to use key names or fingerprints. This is a personal decision. I like to see the key names in the prompts that we get. You'll see that in a moment, so I'm going to click Use Key Names. So here we have a snippet that allows us to configure our SSH config so that all SSH requests use the 1Password SSH agent. There's a snippet of code here that we can copy, use the copy snippet button, or we can click this button and it will automatically update the file with this piece of code. So we're going to click Edit Automatically, and now the SSH agent is set up and running. So now that we have an SSH key in our private vault, the SSH agent in the 1Password application enabled and running, we need to add our public key to our GitHub account so that GitHub can authenticate us when we push our code. To do that, we're going to head back to our browser, our GitHub account settings under SSH and GPG keys, and we're going to click here to create a new SSH key. With the 1Password browser extension, we can automatically fill keys from our vault. So if we click in the key field, you can see the GitHub demo auth key that we just created is here and fillable. This fills the public key and the title. We leave this drop down as authentication key because this is the key that we're going to be using to authenticate our actions with GitHub. And now on our account, we have the GitHub demo auth key. This will allow us to push code to GitHub from our local repository. So let's head over to our IDE. So now we're ready to make some changes to our local application. Let's go ahead and make some changes to the README file here. Once we've done that, we can commit those changes to the local repository and push the changes up to GitHub. You'll see here the 1Password application presents us with an authorization prompt that gives us all the information we need. We're allowing Golang to use the SSH key, this SSH key specifically, the GitHub demo auth key that we just created. And it allows us to authorize with Touch ID. This would also allow us to authorize with Apple Watch, Windows Hello on Windows, or Linux System Authentication on Linux. Alternatively, on all platforms, it would allow us to authorize with our 1Password account password. I'll go ahead and put my finger on the fingerprint reader, and the push has successfully been made to GitHub. So let's take a look at that on the GitHub UI. Over here, we have our demo app. If we refresh this, you'll see this change was pushed to GitHub and authorized with SSH. And our initial commit here, it's been made successfully. However, one thing it's missing is the verification badge. Verifying a commit is done by cryptographically signing the commit with an SSH key. This is important to prevent spoofing of accounts, because it is possible, for example, for someone else to take your GitHub account email, set that as their Git email locally on their machine, and push code to GitHub. And on GitHub, it will appear as if you made that commit. However, signing your commits with a key allows us to verify that it was actually you who made the commit. So let's go ahead and do that now. We're going to head back to the SSH and GPG keys section in our account settings, and we're going to create a new SSH key. If you remember last time, we created the SSH key inside the 1Password application and then used the browser extension to fill it in these fields. This time, we're going to select signing key from the drop-down. We're going to click on the key field, and we're going to create an SSH key directly from the browser extension. GitHub demo signing key. We're going to use the same type of key, and we're going to create and fill that key. We're going to go ahead and add that key to our account. You'll see now we have the GitHub demo auth key that we created earlier and the GitHub demo signing key that we just created now. If we take a look back at our 1Password application, we'll see that that's also been added to our vault as a separate key. You also notice this banner on the key. The next step is to sign your Git commits. To verify the authenticity of your Git commits, you can set up Git commit signing with SSH, no GPG needed. So we can click this button here to configure this. And again, same as when we were setting up the SSH agent, to configure Git commit signing, there's a snippet of code here that we need to add to a config file. We can manually copy it, we can copy the entire snippet with a button, or we can click edit automatically and it will make the changes to the file necessary. We're going to go ahead and do that this time. So we've successfully configured. Your next commit will be signed with this key. That's wonderful. So let's head back to our code. So now we're ready to make another change to our local files, and this time commit it with a signed and verified commit. So let's go ahead and make that change to our README file, and then commit that change. You'll see again, we get an authorization prompt from the 1Password application. However, this one's different. Last time it was for the GitHub demo auth key, whereas this time it's for the GitHub demo signing key, which we just created. This is an important distinction to make because this auth prompt is authorizing Golang to use the signing key to sign the commit. So if I go ahead and put my finger on the fingerprint reader, we authorize that with Touch ID. And we're going to go ahead and push that up to GitHub again. And we authorize with our fingerprint. So now the only thing left to do is head back to the GitHub UI and check whether our commit was successfully signed. The commit's here, so let's click it and have a look. We've got the verified badge. So in just a series of a few clicks, we've managed to create an SSH key, autofill the SSH key in our GitHub account settings, use that key for authentication with GitHub, activate the SSH agent, and or automatically edit our configuration files, create another SSH key, configure that for Git Commit signing, and activate Git Commit signing in the 1Password application. The story doesn't stop here, however. Once we've successfully pushed our code to GitHub, we often want to configure our repository to automatically run GitHub Actions as a result. These GitHub Actions often require their own credentials and secrets to be injected. I'll pass you over to Dustin, and he can explain how we do that.
Hi everyone, my name is Dustin. I'm a developer here at 1Password, and I work on the infrastructure secrets team. Today I'm going to be demonstrating how we can use 1Password's VSCode extension and 1Password service accounts in order to help keep sensitive secrets out of our Git repositories. So my team and I have this demo library repo here, and it's available to install through npm. This file that I'm showing, release.yaml, it's a GitHub Actions CI/CD workflow that releases a new version of our library and then publishes it to the public npm registry. Note that we need an npm token to authenticate this action, but as you can see here on line 29, I've made the mistake of hard-coding my npm token as a plain text secret and committing it. This token is now exposed in two different ways. One, it's vulnerable to malware that could steal it from my local disk, and two, it's vulnerable to any bad actors who can gain access to my Git repository. So wouldn't it be great if we had a way to pull this token out of our code base and store it in 1Password and then replace this plain text value with a path that references the secret? This is where our VSCode extension can help us out. So in my 1Password account here, I've created this dedicated vault for these called CI/CD. And as you can see right now, it's an empty vault. If I go to VSCode, click on extensions, and type in 1Password, I'll install it. Go back to my file here. I'll press Command-Shift-P to open up VSCode's command palette. And if I type in 1Password, it gives me a few different command options. So I'll do choose account here and confirm that I'm using my personal test account. And I'll do that one more time, and I'll choose my vault. So you can see here that 1Password's prompting me for my fingerprint to authorize the VSCode extension. I'm going to put my finger on the reader to allow that, and I'll select the CI/CD vault that I just showed. So now down here, right above line 29, you can see that we have this Save in 1Password button. If I click on this at the top here, it's asking me what I want to call the item. I'll say npm_token, press enter, and then it's asking me what I want to call the field. Token is fine, so I'll press enter there. Now, as you can see, we've replaced our hard-coded secret with a path in 1Password where that secret now lives. So I made this into a string, and I'll remove this section UUID to make this a little more readable. And then to walk you through how this secret reference syntax works, OP is the protocol that we use at 1Password, CI/CD is the vault name, npm token is the item name, and then token is the field on the item. If I hold down Command on my keyboard and click on this, we can actually go directly into 1Password and look at it here. Perfect, so we have the token out of the code base and in 1Password. It's also worth noting that if you had a pre-existing secret that's already in 1Password and you wanted the reference field for it, you can actually click here and say copy secret reference to get that path on your clipboard. And you can then paste it into your app code. Okay, so something worth mentioning here is that we could be using GitHub's built-in repository secrets feature to store our token. But if you're using credentials like this npm token in multiple places outside of GitHub or even in multiple repos, This makes maintaining these credentials much more difficult, as you'll now have multiple sources of truth where it lives. This becomes especially problematic when you need to change your token, since you'll then need to update it everywhere else. This problem is often referred to as secret sprawl. So now that we've replaced our hard-coded plaintext token with a 1Password secret reference, how do we actually access this secret in our job? This is where 1Password service accounts come in. So typically when accessing your secrets from 1Password, you need to provide your username, your password, and your secret key. This is not ideal in an automated scenario like a CI/CD job, since using these credentials would grant access to all of your vaults and all of your items. Service accounts are ideal for shared environments because they provide an authentication method to 1Password that isn't tied to an individual like a username is. And it also allows for you to limit the scope of access to just the vaults that you select. This helps minimize the secrets that the service account token can access, which is very helpful if your token ever gets compromised. So with all of that being said, let's set up a service account. I'm signed into my account here on 1password.com, and if I go over here to integrations, under this infrastructure secrets management section, I'll click on GitHub Actions, and then I'll click create a service account. It's helpfully pre-filled the name for me, so I'll click next. Now here I can allow the service account to create new vaults, but the only thing I really need is for it to access that CI/CD vault, and it only needs read access, so I'll leave this as is. When I create the account, I'm presented with the token, and it's important to note that we won't show this token to you again after you leave this page, so you should either store it in 1Password if you need to reference it again in the future, or copy it directly into the environment that you're going to be using it in. So I'll copy it to my clipboard. I'll go to my GitHub repo here, in the repo settings, and then in the secrets and variables section under actions, I'll click on new repository secret. The name that we use for these is OP service account token, and the secret value, I just paste it right in here. When I add the secret, I can see that it's now available. And now we need to basically update our GitHub workflow file here to use this service account token to be able to retrieve our NPM token. So 1Password actually has an official GitHub action for this, and it's called the load secrets action. So I've just updated this file a little bit with a quick copy paste. You can see here that we now have another step here. I've given it an ID of OP credentials, and we're using that load secrets GitHub action that I just mentioned. Down here in the environment, we get the OP service account token from the GitHub secrets, as you can see here, and then we pass in a secret reference to where our NPM token lives in 1Password. And then down here, this is where we had the secret reference before. I've just updated this to say from the steps, specifically the OP credentials step that we defined above, it has outputs, and in those outputs we have an NPM token. So that is how we get the NPM token within the GitHub action using this load secrets action. Okay, so that was a lot. Now to see if all of this works. So I'm going to commit my changes here, and I'll say feature, do a release. As Chris showed before, we have these nice auth prompts, so I'm going to authorize 1Password to use my signing key to sign my commit. I'll push that up. Now I have a GitHub Authentication key. I'll authorize that as well. Perfect, so it got pushed. Now for the moment of truth. Let's refresh our repo here. You can see that we have a job kicked off, and I'm currently on version 1.0.2. So let's go into our GitHub Actions. We'll check the release, see how that's going. Perfect, so it looks like our job succeeded. We got the secrets out of 1Password. You can see that they're concealed from the logs, and it looks like everything worked. If I go back to my repo homepage here, you can see that we're now on version 1.1.0, and I can also check that on NPM. If I refresh this page here, we're now on 1.1.0. Okay, so that's about it for this demo. One thing to note before I go, What's really nice about the service accounts feature that I just showed here, its usage isn't just limited to GitHub Actions. You can create your own tools and integrations using service accounts with the 1Password CLI application as well. So that's it for my demo. Thanks a lot for watching.